Okay, so I got a student request for help with this topic, identifying hydrogen bonding interactions between molecules. So before we begin, let's define what a hydrogen bond is. A hydrogen bond is, let me pull my pad over here. A hydrogen bond is a transient intermolecular force between a hydrogen that's bonded to an electronegative element, which I'm going to write as E right now, and another electronegative element. Okay, so suppose you have some kind of E over here, electronegative element. By the way, electronegative element is equal to either oxygen, fluorine, or nitrogen. My notepad is a little wonky right now, so you have to bear with me. So if I can move my computer, maybe that'll help. A little wonky. Let's see. Okay, so where E is either oxygen, fluorine, or nitrogen. Okay, where am I? Now this hydrogen bond is considered to be the electrostatic interaction between these. This is the hydrogen bond, okay, right there. Okay, so an example of a hydrogen bond might be if I have fluorine, which is bonded to something, right? Fluorine has 3 lone pairs of electrons, and a water molecule. Right? Do you see how both F and O are up here, right? So then this would be an example of a hydrogen bond. Okay. Another example might be where I have fluorine and another molecule over here, let's say HF. Okay. And can you see that I have in this scenario, I've got a hydrogen which is bonded to an electronegative element and another electronegative element over here, and they can interact, okay? So these are all hydrogen bonds where the E has got to be some member of this list up here, right? And then there's got to be a hydrogen which is on that electronegative element. So we'll go, let's look through here, and I think we'll find that in each case, pretty simple scenario. Okay, so first of all, do you see how I have an electronegative element right here? There's my oxygen, and I have a hydrogen that's bonded to it, right? So I could have a hydrogen bond between 2 molecules of the same compound, because I might have, let me draw this first one out here. Let me go to new what is up with my notepad? Just a minute here. Okay, there we go. Okay, let's get rid of that layer. And now let's say that was, I think, acetate. So we had hydrogen, oxygen, carbon, right? Boy, this is really ugly. I'm sorry. Oxygen, hydrogen, right? So I'm drawing 2 molecules of that thing, right? Let me go back over here. You see it? That's that part right there that I'm drawing, okay, formic acid. So let me come back over here, and I've got a hydrogen, which is bonded to an electronegative element, and then another electronegative element. There's my hydrogen bond, okay? So yes, I can get an interaction between that, and what about one of these guys with water? Could that work with water? Let me come back over here. I'm going to draw another molecule of this. Right? And what about a water molecule over here? Okay? And can you see I can get a hydrogen bond there too, right? Okay, a little thin on time here, so I'm going to run down through these here and say, here's an electronegative element and a hydrogen that's bonded to it, and looks like I'm going to be able to either I'm going to be able to make a hydrogen bond there between that nitrogen and another hydrogen, which is bonded to a nitrogen, so yes. And over here, if I have a water molecule, I might have a hydrogen here from the water molecule bonding to that, sure. Or an oxygen, which is bonded to that, hydrogen bonded to that, right? So yes, that's definitely true. And what about chloromethane? Well, I don't have any electronegative elements in there, right? There's no F, O, or N in here. So no, this is not going to work. And it's not going to work, since I have no FO or N, it's not going to work between that and water either. Okay? All right, so that's how hydrogen bonding works. If that doesn't make sense, I encourage you to go back and start the video again. It's a little bit short, but the entire definition is nested here in this red right here. That's the entire definition of hydrogen bonding. And if you use those facts as criteria, I think you'll find that you get it right relatively easily every time. If not, bring it to class to me and we'll talk more about it. Okay, good luck to you.